Hello children, today we are going to discuss about unit vectors. Already we got introduction about unit vectors. We have just seen the formula of unit vectors. So today we will be studying in detail about unit vectors and we will do some problems. Then how to add vectors in which is in the Cartesian form. So this is the topic which we are going to discuss today. So unit vectors. Sometimes we will have to tell only the direction of a vector without magnitude. Okay, sometimes we will have to just mention the direction alone of the vector. So a vector which has got magnitude and it has got direction also. So a vector will have magnitude and the direction also will be associated with that. Sometimes we don't need to mention magnitude, we just need to mention only the direction. That time we will have to use unit vector also. So suppose a vector is this. Okay, so 1 2 3. Okay, so this vector is of 3 units. Okay, so suppose if we take this part alone, its magnitude is 1, then we have taken the direction. This is what is actually unit vector. If this is vector A, this is vector A, its direction is this. This vector A's magnitude is 3 units. Okay, now we just need to mention only the direction. We cut a part of vector A which is of magnitude 1 and we mention the direction. So this is what is the unit vector of vector A. We put a cap there. Okay, then one point is magnitude of unit vector is unity or 1. Magnitude of unit vector is 1. Okay, then another point is unit vector is a dimensionless quantity. Dimensionless quantity. It doesn't have any dimension, it doesn't have any unit also. Its purpose is just to show the direction. Okay, note it down. So unit vector is just to show direction. It is just to show direction. Suppose if we write a vector, how to address a vector, how to write a vector. Okay, vector A arrow. So this is equal to, first one is magnitude of A. Magnitude of A. Okay, into direction of A. Okay, a vector A consists of magnitude of that one, magnitude of A into direction of A. So vector A is nothing but magnitude of A, direction of A. The combination of these two is what is vector. So how can we write? Suppose vector A, magnitude of vector A we write as mod A. Magnitude of vector A into direction of vector A, direction alone, nothing but its unit vector. Clear? So multiplying magnitude with the unit vector will not make any change because it is just like 3 into 1 is nothing but 3. Just like that, its magnitude is what? magnitude of unit vector is nothing but 1, so it will not make any change. Clear? So we can write vector A is nothing but magnitude of vector A into unit vector. So okay, this is what is a vector. Okay, its magnitude into its direction. So what is the formula of unit vector then? This by this, vector A divided by magnitude of vector A. Clear? Okay, this is how that formula comes. Suppose if we draw a vector like this, if this is vector A, 1, 2, 3. So what is vector A here? 1, 2, 3, its magnitude. Okay, magnitude into unit vector direction. So vector A is nothing but 1, 2, 3. This is its magnitude, and this unit vector is nothing but the direction of vector A. Clear? Next is orthogonal unit vectors. Orthogonal unit vectors means the vectors which are mutually perpendicular. The angle between orthogonal vector means two vectors are orthogonal. If we say, then those two vectors will be at an angle 90 degree, or angle between those two vectors will be 90 degree. So orthogonal unit vectors. So orthogonal unit vectors are nothing but the vectors. Suppose if this is x-axis, y-axis, and the axis which is coming to you, this is what is z-axis. Since I cannot draw that in the board, I draw like this. Okay, so the unit vectors, the unit vector in order to show the direction in the x-axis is nothing but I. The unit vector in order to show the direction in y-axis is nothing but j. The unit vector in order to show the direction in the z-axis is k. So I, j, k. Okay, they are mutually perpendicular. Mutually perpendicular. The angle between I and k, 90 degree. The angle between I and j, this is 90 degree. The angle between j and k, this is also 90 degree. So between them they are unit vectors. So these are okay angles. Clear? So suppose if we need to show the direction of any vector, suppose if I need to show this is the direction, this is towards you. So if I show this as a vector, this is head, this is tail, then it has direction along x-axis also, along y-axis also, along z-axis also. Okay, the coordinates are there. So any vector in any direction, okay, whether it is 1 dimension, 2 dimension, 3 dimension, everything can be shown by using I, j, k. Okay, so any direction is a combination. Any direction is a combination of x, y, z. So we use what? Unit vectors. We use unit vectors I, j, k to show any vector, in any direction. Okay, so I, j, k can be used to show any vector in any direction. So we'll practice this. Represent the following vectors. Vector A has magnitude 5 units. Vector A has magnitude 5 units and is in the direction of x-axis. So how to address this? So 5 units. So any vector, say vector A is nothing but its magnitude and its unit vector. So vector A, its magnitude is given as 5 units and is in the direction of x-axis. So unit vector of A is nothing but in the x-axis. So we will put I. So magnitude into unit vector. Vector B has magnitude 4 unit and is in the direction of z-axis. So vector B is nothing but magnitude of vector B into unit vector of vector B. So magnitude of vector B is 4. Then direction of vector B is in which direction? Z-axis. So unit vector, in order to show z-axis, is nothing but k. Third one, vector C has magnitude 2 units and is in the direction of minus x-axis. So vector C is equal to magnitude of vector C into unit vector of vector C. Magnitude of vector C is nothing but 2 and it is in the direction of minus x-axis, means minus I. So I will put the minus here, then I here. Okay, this is how we should address, we should represent vector which is the multiplication of its magnitude and unit vector. Vector D has magnitude 3 units in x direction and 4 units in y direction. So here vector D is equal to magnitude of vector D into unit vector of vector D. So here this has got 2 components. We have studied in the last session vector components. So a vector, if this is a vector that is at an angle, we can make 2 components, y-axis, z-axis, or if it is in the inclined plane, parallel, perpendicular, parallel. So we can make vectors, we can divide into 2 angles. The vectors which are at 2 directions, we can make the resultant also. So same situation. So vector D has got 3 units. The magnitude is 3 in x direction. So its unit vector is I because of x direction. Then plus 4 units in y direction. So magnitude is 4 in which direction? Y direction. So we will have to put J. Okay, so 3 units in x direction plus 4 units in y direction. Then vector E. Vector E has got magnitude. Vector E has got magnitude 7 units in y direction. So 7 y direction. So J, and 5 units in minus z direction. So minus 5k. Okay, this is how we can represent vectors. So its magnitude in one direction into its unit vector. See this question, refer to the figure and find. Refer to the figure and find. So this is the figure. Vector A is given at an angle theta with the horizontal. So we need to find what is A, what is AY, all these things. Just for a practice, for getting comfortable with the vectors. Some students have some fear on vectors. That is because of lack of basics. Okay, when we see vector, when we see this IJK, we'll feel insecure. That should not happen. So that is why this practice is done. Okay, so understand and study. AX. What is AX? AX is nothing but this component. This is what is AX. When we can resolve vector into 2 components. We have studied in the last session. Okay, so AX is what? A cos theta, and AY is nothing but A sin theta. That's it, over. So if a vector is given, its x component or horizontal component is nothing but A cos theta, and we need not by heart. If theta is given here, this is going to be A sin theta. Okay, see, if suppose A is given, if theta is given here, then this is going to be A cos theta and this is going to be A Sin theta, if theta is given here. Okay, so a cos theta, this is a sin theta. Clear? Now how to write vector ax alone? So ax alone is nothing but magnitude of ax into the unit vector of ax. So this is nothing but what is magnitude of ax? A cos theta. What is unit vector in x direction? I. Done. What is ay? Same thing. Magnitude of ay vector into unit vector of ay vector. So a sin theta into j cap. Clear? Okay, so now what we need to write a in Cartesian form. So Cartesian form is nothing but in the form of I, j, k. We have seen, no, 3i plus 2j plus 3k. Likewise, okay, writing the vector together, okay, with all the components of its vectors with its directions. Okay, so here vector a is nothing but its x component, horizontal component is also there, vertical component is also there. So a in Cartesian form is nothing but a cos theta I plus a sin theta j. That's it. Its x component along with unit vectors plus its y component along with unit vectors. If z component is there, that also we need to write. Okay, clear? Okay, what is magnitude of vector a? Magnitude of vector a is nothing but root of each component's square. Okay, simply this is nothing but magnitude of vector a is nothing but a. Or if we need to understand how it comes, then a square sin square theta. This is its x component. This is its x component. So a square cos square theta plus a square sin square theta. So if we take a outside, sin square theta plus cos square theta will become 1. Root of a square will come, that will be a. Okay, clear? Seventh one, root of ax square plus ay square. So root of a square cos square theta plus a square sin square theta. Okay, a square cos square theta plus a square sin square theta. So if we take a square outside, this will become cos square theta plus sin square theta. So this is nothing but 1. So root of a square, finally you will be getting a. Okay. What about tan theta? So tan theta, suppose if we make this as a triangle, okay, if we make this as a triangle using parallel shifting, I can keep this vector here. So this is nothing but ay, which is nothing but a sin theta. So tan theta is nothing but opposite side by adjacent side, ay by ax, ay by ax. So a sin theta by a cos theta, which is nothing but tan theta only. Okay, so a vector a can be addressed like its component along x-axis into I, its component along y-axis into j, and if there is a component along z-axis, that into k. Okay, just like a can be 2i plus 3j plus 3k, something like that. Okay, example. Okay, a vector in its its magnitude in one direction into its unit vector. One direction means x. So its so a vector can be addressed in this way: magnitude into its unit vector in x direction plus magnitude into its component's magnitude y direction into its unit vector in y direction plus magnitude into its unit in z direction. So a three-dimensional vector can be understood like this. Suppose if it is two-dimensional, axi plus ay into j. And suppose if we need to find the magnitude of this vector, root of ax square plus ay square plus az square. If we consider this as the example, its magnitude is nothing but root of 2 square plus 3 square plus 3 square. Okay, so this is equal to root of 4 plus 9 plus 9, root 22. Okay, this is its magnitude. Okay, see this question. Find the magnitude and angle with the positive x-axis of the following vectors. Find the magnitude and angle with the positive x-axis of the following vectors. Okay, so vector A. Vector A is 3i plus 4j. So this is like 3i is this, 3i is this, 4j is this, 4j is this one. So they are asking find the magnitude. First one is magnitude. So magnitude of A is nothing but root of 3 square plus 4 square. 3 square plus 4 square. So 9 plus 16, 25. This is going to be 5. Now what is the angle with the positive x-axis? Positive x-axis is this one. Okay. So this is 4. What is the angle of this vector with the positive x-axis? So parallel shifting, we can place this vector here. Okay. So this is 4. This is theta. So tan theta, how to find the direction? Tan theta is equal to 4 by 3. So remember this triangle always. Remember this triangle. If this is 37, this is 3, this is 4, this is 5. This angle will be 53. This is going to be 90 degree. So sine 37 will be 3 by 5. Cos 37 will be 4 by 5. Tan 37 will be 3 by 4. Same way, sine 57 is 4 by 5. Cos 53. Sine 53 is 4 by 5. Cos 53 is 3 by 5. Tan 53 is 4 by 3. Remember this. So tan theta is 4 by 3 means theta is nothing but opposite by adjacent side. This is going to be 53. So remember this triangle. Okay, lot of places this will come. Clear? So magnitude root of 3 square plus 4 square. Direction with respect to x-axis. Okay, so this is x-axis. We have measured the angle in this way. This is that vector. So tan theta is equal to opposite side by adjacent side 4 by 3. 4 by 3 means from this triangle. Remember this triangle part. This is important. Remember this one. Okay. What about this one? So minus 2i. So if this is x-axis, x and y-axis, minus 2i means this is the vector. Okay, 2 minus 2i. Then minus 2j means this is a minus 2j. Okay, now its magnitude is nothing but root of minus 2 the whole square plus minus 2 the whole square. So 4 plus 4 root 8. This is the magnitude. Okay, now what about the angle with respect to positive x-axis? So this is the resultant. This is the resultant. Using parallel shifting, we can keep this here, this vector. Using parallel shifting, we can keep here. They are asking the angle with the positive x-axis. So positive x-axis means we should measure from here. This is the angle. Okay, so first we will find this angle, then we will merge that. What about this angle? This theta. So tan theta is equal to opposite side by adjacent. So 2 by 2 minus 2 by minus 2. So tan theta is equal to 1 we get. So when theta is equal to 1, what is the angle? Tan theta is equal to 1. What is the angle? Theta is equal to 45 degree. So this is 180 degree. So total angle, okay, with the positive x-axis is nothing but 180 plus 45. This is 225 degree. Okay, 225 degree. Okay, what about this one? Vector C is equal to minus root 3i minus j. So first one, the magnitude is equal to root of minus root 3 the whole square plus minus 1 the whole square. So root of minus root 3 the whole square is 3, and this is going to be 1, and we will be getting what? 2 as the magnitude of C. Okay, now how to find the angle? Okay, so this is minus root 3i and this is minus j. Okay, now this will be the resultant vector. So using parallel shifting, we can put this vector here. This is theta. This is theta. So I am writing here tan theta is equal to opposite side by adjacent side. This is 1 actually, minus 1. So minus 1 by minus root 3. So tan theta is equal to 1 by root 3. So we get theta is equal to 30 degree. Now with the angle with the positive x-axis, this is 180 degree. So theta with x-axis is going to be 180 plus 30. This is going to be 210 degree. Clear? Next question, find the unit vectors in the direction of A is equal to 3i minus 4j. Okay, find the unit vector in the direction of A and B. Okay, so vector A is nothing but magnitude of vector A into its unit vector. So direction of A is nothing but unit vector. Direction of A is what? This unit vector without magnitude. This is what? Direction alone. Of whom? Of A. Okay, so unit vector is nothing but vector divided by its magnitude. So 3i minus 4j divided by root of 3 square plus minus 4 the whole square. So 3i minus 4j divided by, this is going to be 5. Okay, so this is the direction of A. So if we want, we can write in this form, or otherwise we can write 3 by 5i minus 4 by 5j. So this is the unit vector of vector A, or we can say this is the direction of vector A. This is the direction of vector A. Same way, find the unit vector in the direction of B. Unit vector in the direction of B. So unit vector in the direction of B is nothing but vector B divided by magnitude of vector B. So vector B is 5i plus 12j. 5i plus 12j divided by root of 5 square plus 12 square. So 5i plus 12j divided by 25 plus 144. So this is going to be 169. Root of 169 is 13. So we can write 5i plus 12j divided by 13. So this is the direction of B, or unit vector of B. Take this question, students. Find the velocity vector of a particle. Find the velocity vector of a particle moving with 10 meter per second in the direction of R. So find the velocity vector. Okay, moving with the velocity, how much? 10 meter per second. In which direction? In this direction. So what we need is, we need velocity vector, and its magnitude is given as 10 meter per second. In which direction? In this direction. What is its direction? Its unit vector. So this is how. Okay, so it is just like, if this is the unit vector, I mean this is the unit vector R, its magnitude is 1. What we need? We need velocity in this direction. So okay, this is going to be 10 units velocity in which direction? In R direction. Okay, so we will find this. So 10 into unit vector of this one. So what is the unit vector of R? Vector R divided by its magnitude. So 2I minus 3j plus 4k divided by root of 2 square plus minus 3 square plus 4 square. I am writing minus 3 all square for your understanding. It is not going to make any difference if you write plus also. Rather, we can directly write. Just for your understanding, I am writing this. So 2I minus 3j plus 4k divided by 4, 9, 16. Okay, so 16 plus 9, 25, 25 plus 4, 29. So this is going to be root 29. So this is the unit vector of vector R. So velocity vector is nothing but 10 into this one, 2I minus 3j plus 4k divided by root 29. If you want, you can keep in this way, or we can multiply and write 2I minus 30j plus 40k divided by root 29. Okay, this is the velocity vector they are asking. Take this question. If A is equal to 3I plus 4j and B is equal to 7I plus 24j, find a vector having the same magnitude as B. Find a vector having same magnitude as B and parallel to A. So suppose if we are trying to find a vector, we will put a name for this vector C. So this C vector must have the magnitude of B. Magnitude of B is nothing but mod B. Okay, magnitude of B. Okay, and this must be parallel to A. Parallel to A means, suppose if this is vector A, parallel to vector A, okay, whether its magnitude is more or less, we are not worried. It must be parallel to A. Means parallel to A means what? Same direction of A. Same direction of A. Same direction of A. Direction of A is what? Its unit vector. So C must be magnitude of B in the direction of A. So multiplying with the unit vector. Clear? So what is magnitude of B? So root of 7 square plus 24 square. So this is going to be 49 plus, how much will be 24 square? This will come around 576. We will be getting this as 625. So root of 625 is 25. Okay, we will be getting this as 25. Okay, now what is unit vector A? Vector A divided by magnitude of vector A. So vector A is 3I plus 4j divided by magnitude of A is nothing but 3 square plus 4 square. Okay, so 3i plus 4j divided by, this is going to be 5. Okay, now what about c? C is nothing but 25 into 3i plus 4j divided by 5. Okay, so this 525 will be cancelled off. This is again 5. So vector C is nothing but 5 into 3, 15i plus 5 into 4 is 20j. So this is vector C. Okay, a vector which is having the magnitude as b and direction of a, that is parallel to a. Anti-parallel to a means we will have to take the opposite direction of a. We will have to put anti-parallel means -3 -4. Then just we need to take the unit vector and we need to solve it. Now we will see addition of vectors in Cartesian form. So Cartesian form is nothing but vector that is written in the form of I, j, k. Cartesian coordinates are nothing but x, y, z. So addition of vectors, how to add vectors? Addition of vectors in Cartesian form. So how to add vectors graphically using triangle law, parallelogram law, then polygon law we have seen. Then when we get two vectors acting at some angle, how to find the resultant? Okay, these things, that is two vectors, if they are acting at some angle, two magnitudes are available. Okay, two magnitudes are available and they are acting at some angle, we know how to find the resultant by using the formula. But if we are getting two vectors, 2i plus 3j plus 4k, I plus j plus 3k, something like that, how to add? Okay, how it is done? Okay, so this is simple, very easy. Suppose vector A is axi plus ayj plus azk. This x, y, z are subscripts, just to show that this magnitude in I direction, this magnitude in j direction, this magnitude in k direction. Same way, vector B is bxi plus byj plus bzk. Okay, these three vectors. Now just see this. Suppose if A is directed like this, this is vector A, this is vector B. Now suppose if we need to add vector A plus vector B, vector A plus vector B, how to add? This is nothing but ax plus bx into I, just add its I components, plus ay plus by into j plus az plus bz, az plus bz into k. Okay, so this is how a plus b, ax plus, it's just add its corresponding components and write. This is how we need to find. So its resultant in r, just resultant in x direction I plus its resultant in y direction, okay, plus its resultant in z direction. This is how it is done. Okay, clear? Okay, now just to show, just for understanding purpose, I am just removing this z component. Z component I am removing, and I am going to show how this is correct using, because I cannot show in 3-dimensional figure, just I shall show this in 2-dimensional figure. Okay, so suppose if this is vector A, this is vector B. We are claiming that ax plus bx ay plus by of j then I respectively. How this is true? So if this is vector a, this is vector b, what is the resultant of these two vectors? Whether this is in this direction or this direction, in the opposite direction closing the triangle, correct? So if this is the triangle, closing the triangle in the opposite order, correct? Now if we take the resultant of this vector a, this is nothing but ax, this is ay, this is ay, this is ax. If we take the resultant of vector b, then this is bx and this is by. Okay, now we will take the resultant of, we will take the component of this resultant vector, this one. If this one's, this vector's x component and y component, if we take, this is what is rx and this is what is ry. So this rx is nothing but ax plus bx, ry is nothing but ay plus by. So ax plus bx in the I direction, ay plus by in the j direction. So we can take the addition of two vectors in this way. So for if third component is there, z component is there, just like this we will have to add. Suppose if we get two vectors, vector a is 8i plus 6j plus 4k, vector b is 4i plus 3j plus 2k. So what is a plus b? Okay, what is a minus b? So a plus b is nothing but 8 plus 4, 12i, 6 plus 3, 9j plus 4 plus 2, 6k, over, done. A minus b, 8 minus 4, 4i, 6 minus 3, 3j, 4 minus 2 is equal to 2k. Okay, this is what is a plus b and a minus b. So take this question, vector a is this, b is this, c is this. We need to find a minus 2b plus 3c. So 2b is nothing but 2 into 3j minus k. This is scalar, this is vector. Just we can multiply inside, 6j minus 2k. What about 3c? 3 into 6i minus 2k. So 18i minus 6k. Okay, now a minus 2b plus 3c will be what? 2i plus j minus 2b. So this is what is 2b. So minus 6j plus 2k. Okay, just we multiplied with the minus inside, I got this. Then plus 3c, that is nothing but 18i minus 6k. So solve this, 2i, 89, 20i, j minus 6j, no other j is here. So minus 5j. Then 2k minus 6k, minus 4k. Okay, clear? So okay students, this is how vector algebra, just we got the feel of what is unit vector. We know how to resolve the vector, how to find the resultant of the vector. We need to add the vectors. So we are marching in vector algebra. We need to study some more things. We need to study multiplication also. So concentrate on this topic. Do as much problems as possible. Be comfortable with vectors. So wherever vector comes in physics, we will not feel difficulty. Okay students, thank you, goodbye, good luck.